Hi there. So in this screencast, I'm going to be showing you how to um, create an R package with the nearest neighbors C++ code. And so, yeah, the first thing that we're going to do is we're going to be able to get a new text file. And so let's already do Ctrl-S to save this. So you need to create a directory called source to put our C++ source code in our project. And then what we're going to do is we're going to make a file called knn.cpp. And so that's going to be our main implementation of the file that implements the k-nearest neighbors algorithm. And so in our k-nearest neighbors algorithm, what are our inputs and outputs that we need to have? Well, we need to input the data set. So that's well, first of all, let's output the return value for the function. It's going to be a integer error status code, and let's call the algorithm knn. And so let's give the following arguments. So we can use the const keyword to declare that these are going to be inputs to the function that we're not modifying. So const double pointer, how about train inputs pointer, const double pointer train label pointer. And so now let's usually I like to add a comment to have to explain the number of dimensions here. So this is going to be n observations. That's the number of rows by n features. That's the number of columns. And here this is just going to be a vector of n observations. So when I write a comment that says something times something, that's a matrix, and if I just use one size like this, that means it's a vector. Because when we pass a variable like this just as a pointer in C++, we don't really know the dimensions, so it's nice to note that in the comments. So the other parameters to this function are going to be, okay, these dimensions, so int n observations, int n features, oops. And then another parameter is going to be int n neighbors, or we can say max neighbors. How about that? So then we're going to have, so again, these are going to be consts. We can indicate these as consts, so we can know that these are going to be inputs to the function. And likewise, another input that we need is the test data point. So const double test input pointer, and so this is going to be a vector with one test data point with n features, in the size n features. So then what are we going to do? Well, we need to have an output, and so we're going to save the output to this double pointer. How about test predictions pointer? And so what we're going to be doing is for this test data point, we're going to be computing all of the k-nearest neighbors predictions from k equals 1 to max neighbor. So we're going to need a vector of n of max neighbors. That's going to be the size of that vector. All right. So that's just a little skeleton function that we can do. It doesn't do anything yet, but let's already see if it compiles. Use Ctrl-shift-B to compile that, to build that package, right? So tools, profile, build, configure build tools, project build tools, package. That's what we have to do. And then we should check generate documentation with R oxygen. Do that after every build and reload. And let's see if that works. All right, then in the build menu, we indeed have a install and restart. So let's try that. Ctrl-shift-B. Build directory does not contain a description file, so cannot be built as a package. Indeed. So let's create a description file. All right, new text file. Let's save this as description. And so what do we put in our description? Well, we have to put a few things that describe the metadata of the package. So first thing that we have to do is the package name, and it's going to be a package field. So we're going to call that nearest neighbors demo. Second thing, we have to say type equals package. We have to give the title, nearest neighbors demo. We have to give a version. So usually I take the current date as a version number. Author, maintainer. Typically the maintainer is the same as the author, but you also have to indicate an email address. And you have to have a description field with somewhat longer description of the package. Then we have to indicate a license. I usually use the GNU General Public License version 3. And I think those are the minimal fields that we need for the description. So let's just try to rebuild now. All right. So now we can see there are some messages, mostly related to generating the documentation, but that's okay. We use our command install here to build the package, and we can see that G++ is used to compile our C++ code, and that compiles fine, it installs, but we don't have an interface yet. So let's write an interface function for this package. So to do that, what we're going to need to do is we're going to need to create a new file, new text file. Let's save this as in the source directory interface.cpp. And so in the interface.cpp file, what do we need to do? Well, what we need to do is we need to have all of the stuff to tell R how to use this knn function that we just wrote. So the first thing that we need to do is we need to use we need to write a interface function. So that would be in R, an interface function is always going to return void. And typically I call my interface functions with the same name as the main function, but with underscore interface. And so here we go. knn interface is going to have arguments that are all pointers. So let's take a look at that. That's going to be, let's take a look at the same argument list that we have here, but let's turn them all into pointers. All right, so the first ones are already pointers, which is fine. We didn't need to turn these guys into pointers. Let's call this n observations underscore pointer. Let's call this n features underscore pointer. Let's call this max neighbors pointer. So that's just the convention about how to call C++ code from R. Oops, let's do that. And so inside of our in our interface function, we need to create, we just need to call our KNN function. It returns a status code that we're going to save to this status variable. And so what we need to do is we need to just pass all of these things through. Train inputs pointer, train label pointer, test input pointer. And now here we're going to have to dereference the n observations pointer. We're going to have to dereference the n features pointer. And we also have to dereference the max neighbors pointer so we can get the value that's stored at the pointer instead of the address in memory. And then the last thing, we're going to pass this output pointer, which is test predictions pointer. And so this is a very basic interface function, but see, we reference this KNN function, which is not defined in this file, so we're going to need to make a header file to do that. So let's refer to a header file, knn.h, and let's make that header file now. How to do that? See, already it tells us use of undeclared identifier KNN, so let's make that. Text file. So let's save this as knn.h. And so here we're just going to put a prototype of this function. And to do that, we can just copy the function definition, put it here, and then terminate it with a semicolon. That's a prototype. Going back here to interface.cpp, we see that, well, here we actually do still have this this issue, but let's install, rebuild, and see if that still has a problem. It shouldn't be a problem. So indeed, now we have, let's see, unused variable status. Okay, so we get a warning from the compiler here that we haven't used our status variable. We're just storing the output there, but we're not using it. So, I mean, one thing that we typically should do is we should check if the status is 0. If it's not, then we should stop with an error. And to do that in R, actually, we just call the error function non-zero exit status from KNN. So that's just a kind of a generic error message. And so now we're saying use of undeclared identifier error. And so indeed, in this file, error is not defined yet. And so to get a definition of error, we actually have to include R.h. And so if we do that, that should be able to compile. If we put a semicolon there, that will compile. And so yeah, that's working fine. The compile lines are working okay here. But now we still can't call this function, right? So typically we would be able to call this function with .c knn interface. Then we can give it some arguments here. So typically we can do like, for example, let's look at the some data set from how about zip.train from the ElemStatLearn package. So this is a database of handwritten digits. And so if we look at zip.train, there we see it's a numeric matrix with 7,200 rows and 257 columns. We can use this as an example data set to throw into our algorithm. Let's just use a small subset of that data to test our algorithm. So the first column is the label. So let's select all the other columns as our inputs x here. Zip.train -1 will give us all the columns except for the first one. And let's do 1 to, so let's just get the first 5 rows as like a sample data set. So y zip.train, let's just get the first 5 elements as the label, and so then we can see, well, our x, this is this big matrix with 256 columns and 5 rows, but 2 have been omitted in the printout here. And y, it's this vector of labels. So ordinarily, so we can let's also make a test x, which let's say is you know, the next 5 rows. And so ordinarily, like I said, we can pass this to the KNN interface function. If you say as, so basically now we're going to have to match all the arguments here with our interface function. Here, train inputs pointer, well, this is going to be our input matrix x. Train label pointer, this is going to be our input labels y. Train labels y. And so then we're going to also have as.double test x. And here we're gonna have to use as.integer and observations and features and max neighbors. So that's gonna be as.integer n row x, as.integer n call x, and then so actually our test x here, as we've defined it here, it should be just 1 row with n features. So let's redefine that. So how about just, let's take observation number 6 and use that as our test x. So now you can see test x is just a vector with 256 elements that we're going to make a prediction on. Okay, so going back here, we should do as integer length and test x. Oh no, we don't need that, sorry. We already know that's the same length as ncall x. So actually we need to say what is the max number of neighbors, and so let's say how about 3? But we should always have this stored as a variable. So again, let's make another variable called max neighbors equals 3. And then you can go as integer max neighbors, and we just need to pass this a vector of max neighbors elements that we can use to store the output values. So that's going to be double max neighbors. That's going to allocate a vector of doubles with max neighbors elements. And so yeah, it's a little bit complicated, but basically you just have to match up all the arguments in your interface function with your .c call in our command line. And so here we just have to tell the package name where we're going to look for our interface function. But what it tells us is that KNN interface is not available for .c for package nearest neighbors demo. So there's a couple more things that we need to do before we're able to use this interface function. And so the first thing that we need to do is we need to declare this function as an interface function. And the way to do that is, well, first we're going to add include r_x/Rdynload.h. And so this is going to give us access to some functions that we're going to use down here to define our interface functions. So here we're going to have to declare an object with the type R underscore C method def. There we go. It completes for us. How nice. We're going to call this C method, and it's going to be an array of objects like this, where every entry is going to be, well, the first thing is going to be the name that we're going to use for this interface function, KNN interface. The second thing is going to be a pointer to the function that we're going to use. There we go. We have to cast it to a dlfunc type object. And so using the and sign here gets us the pointer to the KNN interface function. And then third argument we need to do is we need to pass the number of our arguments that we use here. And here there's 7 arguments, so we're going to put 7. And then the last thing that we need to do in this file is extern C, which tells us that this next block is going to be viewable by C code, even though it's a C++ file. And we need to define a function that returns void, and it's called R underscore init underscore whatever your package name is. And here it's nearest neighbors demo. And here it's going to take an object, DLL info, which is defined in R, and we just need to call 2 functions. The first one, R underscore register routines. We give info as the first argument, and then C methods as the second argument, and then we can leave the last 3 arguments null. Oops. And the second thing, we use R underscore use dynamic symbols. There we go. It completes. How nice. And then we have to pass info and then true or false. And so false means it's not going to search this shared object file unless we specifically tell it to. So that's a bit of an efficiency thing. Anyway, so this is kind of just like the boilerplate interface code that you're going to need to use in your own package. But let's recompile and see what happens. All right, so everything compiles fine, but it still shouldn't quite work. KNN interface is still not available for .c, and the reason why is because we need to add one more file in the package called NAMESPACE. Actually, there is a NAMESPACE file already, so let's just open that up. And we need to add useDynLib nearest neighbors demo. And so that's just telling it to, or I don't think we need the quotation marks. So let's try that, try to rebuild that. Exited with status. Okay, that's odd. So what's going on there? Well, I'm not sure what's going on there, but maybe it's because we haven't exported anything in the namespace. So typically you use something like exportPattern here, and it's going to tell the package to export all of the R objects that are defined in this package. So let's see if that changes anything. No, it still doesn't, but okay, so why don't we take off this documentation generation for now. So tools, project options, code editing, no, build tools, generate documentation, let's turn that off. testing if installed package can be loaded. Loading failed. Now why is that? So